The continuation of paper 6, February March 2018, question number 3. A student is investigating a circuit containing different lamps. She is using the circuit shown in figure 3.1. A power supply is there. You can see two lamps are X and Y are there, and then there's an ammeter. On a figure 3.1, draw a voltmeter connected so that it measure a potential across lamp X. Only for potential across lamp X. You can use a screen annotation to complete this part. Even up or down does not make difference. You can draw the voltmeter here as well. That does not make difference to the final value. A student uses the ammeter to measure the current in the circuit. Record the current IS. What is the value of the current shown in the meter? So 0.34 amperes. If in the blank the unit is not written, so you have to write a unit. From 0 to, you can see 10 lines are there, so each line is representing 0.02. And 0.02 multiplied by how many lines are there? That's 17. So 17 multiplied by 0.02, you will get 0.34 ampere. The next part, the student uses the voltmeter to measure a potential across lamp X and a potential across lamp Y. Record the value of potential across X and Y. What is the value for potential of X, the voltage reading? X is 1.2. And what about Y? That's 1.9. So 1.2 volts and 1.9 volts. She then measured the potential across both lamps in series, and the total voltage is coming out. What is Vs, value of the Vs? The total voltage, that's 1.3, 3 volts, yeah. And a student suggested that Vs should be equal to Vx plus Vy. So Vx was 1.2 and Vy is 1.9 and Vs is 3. So this was 1.2 practical, because as I mentioned that practically when you're doing the experiment, it's not like the results are 100% same. So what you have to do, you have to check percentage difference. Students suggested that when we add Vx and Vy, we will get Vs. So when we add Vx and Vy, that value will be 3.1 and Vs is 3 volts. So if I want to show that two values are same or two values are equal, I can work out by a percentage difference. So when statement will be yes, the two values will be equal within limit of experimental accuracy, the two values are equal to each other. So statement, you can say yes, Vx plus Vy is equals to Vs, and justification, Vx plus Vy is 3.1, which is approximately equal to 3 within experimental accuracy. The percentage difference will be less than 10%. I did not calculate a percentage difference here, but when you calculate, you will find it will be less than 10%. Calculate the value of VR. The percentage difference is 3.27, so it is clearly less than 10%. Calculate the value of R1 of lamp X using the reading. So R1 is Vx over Is. So Vx was 1.2 and Is was the total current, the first answer, that was 3.4, I think. Sorry, 0.34. What is the reading? 1.2 divided by 0.34, 3.5 ohms. So you can write your answer 3.53 or 3.5. Both are correct. The circuit components are to be rearranged so that the lamp X and Y are in parallel. The ammeter measure the current in X only and the voltmeter to measure potential across the lamp. So I want everyone to use the screen annotation to draw. You can use any part of the screen to draw your circuit. Lamp X and Y are in parallel. Then there is ammeter to measure a current in X and a voltmeter to measure the voltage across the lamps. It's better you use standard circuit symbols. Ammeter to measure, we need an ammeter to measure current in only one of the lamp. Ammeter to measure current in lamp X.
So the lamp above is X.
Which one? This you mean? This is a lamp.
Yeah.
And
Yeah.
this is ammeter.
Yeah.
Yes, continue motion. You can go. Yeah, the voltmeter will measure the total voltage. That's right. Because they're in parallel, even I can connect a voltmeter across the battery. That's right. The next question, the student set up the circuit as described in E2 and she measure and record the current X in lamp X and potential across the lamps. She then calculated the new resistance R2 of lamp X in parallel. The student noticed that X is very bright in parallel, but it was dim in series. Suggests how the temperature affects the resistance of a lamp. As you can see, this is the resistance of a lamp in parallel, 8.3, the lamp X. And when we work out the resistance here for lamp X, it was 3.5. So it was 3.5 ohms, and now it is 8.3. It appeared to be have a high resistance. So in the question they are asking, that student noticed that the lamp X is very bright in a parallel circuit, but it was dim in a series circuit. Suggest how the temperature affects the resistance of a lamp, and justify your answer with reference to value of R1 from D and R2. As you can clearly see, the same lamp which was having, because when you use the lamp will become, it produces heat, so it become warm. So when we were using the circuit in the first one, the lamp X and Y were in series with each other, and it was having a resistance of 3.5. But what we did, we replace and we connect the two lamps in parallel, and when we calculate the resistance of this lamp X, it was coming out 8.3 ohm. That is dimension in the question. So why the resistance, even the lamp is the same, but why the resistance increased? As we know, resistance and temperature are directly proportional. So it means as the lamp was used in the first circuit, it become warm. As it become warm, its temperature increase. That's why the resistance increases. And the question they are asking suggests how the temperature affects the resistance. So how the temperature is affecting the resistance? As we know, the value of the R2 is more than or greater than R1, and the second circuit, the temperature of the lamp is higher. That's why it is having a high resistance. And it is brighter, because when the lamp is brighter, it means it is at high temperature as well. So R2 is more than R1, and the lamp is brighter. It shows it has high temperature as well. So temperature and resistance are directly proportional. When the lamp become brighter, it means that the temperature of the lamp is higher than the normal one, and when its temperature is higher, its resistance will also increase. So basically, this statement is showing that lamp is brighter, it means its temperature is higher. And when we compare the results, in parallel circuit, the one which is having a high resistance will have more voltage. In series circuit, the one which will have high resistance will have a more voltage, it will be brighter. But in a parallel circuit, the filament lamp, it depends on I square R. So higher resistance, more power is there, so it will be brighter. In lamps are made up of filament, and these filament is made up of tungsten. Tungsten is a metal, and its in temperature increases, and temperature and resistance are directly proportional. So if we use a lamp for a longer period of a time, it means its temperature will increase. As the temperature increase, resistance will also increase, and the power will decide the brightness. Not about it's the total idea is about the power. Greater power means brighter lamp. And you can see we have the formula P is equals to I square R, because in series circuits, if the resistance increases, the power of the lamp will also increase. The last part is the planning of experiment. A student is investigating the factor that affects the size of a crater a hole a ball makes when it drops from into a sand. Plan an experiment which would enable to investigate one factor which might affect the size of the crater. The operators available include the metal ball of different size, a tray of a sand. These are the two things available. We have a tray of a sand, like this is a tray which is filled with the sand. A metal ball is there. So in your plan, you should state the factor which is being investigated. Which factor you are investigating, like what you are finding, the factor which might change, the possible factor, height of dropping, like, and the mass of the ball, the size of the ball. These can be a possible factors, because the factor which we are investigating, we can investigate the surface area of the ball can be investigated, the size of the crater. So which fact, it's up to you which factor you are investigating. According to that, you have to write an answer. Size of the crater or the size of the hole you can also mention. I'm taking one of them because metal balls of different sizes are there. So because I have to take one of them, otherwise if I take all the answers, I have to plan only for one of them. State which factor is being investigated, like which factor you want to investigate. Example, we are investigating the size of the crater. State the key variable that you would control. Variables means plural. So if you are comparing the size of the crater produced by these balls, what variable we should control? We have metal ball of different sizes, or the height. Even I can compare the height of dropping. So what variables I should control here? Even you can, instead of size of the crater, you can also compare the depth of the crater, like how deep it will create a crater or a hole. Yeah, amount of sand, that's one thing. Or the height of the sand in the tray, that's one factor. What else? If I'm comparing how deep the crater is produced, I have metal balls of different sizes. Time is not affecting, because and it's not about the time, because the time does not have any influence here. The height from which I'm dropping these balls, I should drop these balls from the same height to identify how deep the crater is produced by these different balls. What else? The amount of sand, the depth of the sand, the height of dropping. Gravity, we cannot control gravity. The size of the crater, look, even though the balls have the dimension, metal balls of different sizes. So how the size of the crater will be different? It depends on, like example, if this ball is dropped, if it does not go deep inside, then the size of the crater will be this much only. Small size crater is produced. But the same ball, if it go deep inside in the sand, then the size of the crater will be different. Depth will be different as well as the size of the crater will be different. This will produce a bigger crater as compared to the same ball which is dropped. So amount of the sand which you are using, the height from which it is dropped, the balls are dropped, and the surrounding conditions such as air speed. The next part, list an additional apparatus needed. What else we need for this experiment? The air speed or air current, that's true. So we need a meter rule or a measuring tape to measure the size of the crater or the depth. So meter rule or measuring tape. Explain briefly how would you explain briefly how you will find uh, explain briefly how could you carry out experiment, include what you measure and how you do this or how this would be done. Regarding the masses, because they mentioned metal ball of different sizes, so you can mention a mass for measuring a mass or balance can be used if you want to include the masses in your answer. So first we'll mark the point of a dropping, the point of position where we are dropping, that measure the height. So example 20 centimeter above the sand, then drop the ball of different sizes one by one, and for each ball measure the depth of a crater. Yeah, that's good. And repeat the procedure. You should, whenever you're doing experiment, you should repeat as well and avoid parallax error. That is mentioned in the state of precaution that you will take to ensure that the results are accurate as possible, reliable results are there. So for reliable results, state one precaution you should take to obtain a reliable result. You should avoid a parallax error. Look perpendicular, repeat, take an average. Because you are using a ruler, so you should avoid a parallax error. By looking perpendicular. And repeat the procedure, calculate or take an average. Suggest a suitable graph which you could draw for the result. So plot a graph between depth of the crater and the size of the ball. And when you mention the graph, you should mention what you will plot on x-axis and what you will plot on y-axis. It's up to you, but you should mention. Is it clear? This experiment in which we investigate, because what in this experiment they make it this open experiment that you can investigate any factor, because they mentioned a student in investigating the factors. So he's investigating a factor. So still there is one mark missing, we did not include. Then the last thing what we will write, we'll write repeat the experiment with, like the first one we are investigating the depth of the crater. The second one, what we can do, we can calculate the height from which the ball is dropped. Investigate with the second factor. That will give you 1 mark, because in the question it is clearly mentioned that student is investigating the factors, but we did just only write for one, so we don't have to write the whole experiment again. Just one more line at the end, we'll write repeat the experiment and investigate the effect of height from which the ball is dropped on the size of the crater. Is it clear, this whole experiment? So this is February, March